Foundations of Amateur Radio. The single most discussed topic in amateur radio is that of antenna design. That and medical procedures on 80 meters, but I kid. Previously, I've discussed the notion that all frequencies are on air all the time, and that your traditional radio uses much of its electronic circuitry to filter out all the things you don't want to hear. Parallel to that is the concept that you tune your antenna to be resonant on a particular band or frequency. As amateurs, we might look for a wideband antenna that makes it possible to use our radio across several bands. We often construct our antennas to be multiple harmonics of a band, so we can have access to more spectrum without needing more physical antennas. None of this is new, and as an amateur, you'll likely spend the rest of your days improving your antenna situation, or at least talking about it, if not outright bemoaning the lack of antenna space, family approval, budget, or some other excuse. As I started my journey into software-defined radio, a new idea occurred to me. If an antenna is a resonant circuit, could you think of your antenna as a filter, as in something that leaves out the things you don't care about? In and of itself, I'm sure I'm not the first to consider this notion, but the idea means that you essentially turn your idea of an antenna on its head, from something that receives to something that rejects. Consider, for example, the small transmitting loop antenna, often also called a magnetic loop antenna. It's got one characteristic that isn't often considered a benefit. It has something called a high Q, or a high quality factor. The higher the Q, the narrower the bandwidth. I should digress here for a moment. Q is a number. Big number means narrow bandwidth, little number means wide bandwidth. It's easy to calculate. If you look at an SWR plot of an antenna, you'll see a curve where the bottom of the curve is the lowest SWR of your antenna. That's the center frequency. You'll also see 2 points on the same curve, where the SWR hits 2 to 1. If you take the center frequency and divide that by the difference between the two edge frequencies, you'll have the Q of that antenna. Using numbers, consider an antenna that's got an SWR below 2, between say 7 MHz and 7.2 MHz, a bandwidth of 200 kHz, you'd have a center frequency of 7.1 MHz. The Q of that antenna would be 7100 divided by 200, or a Q of 35.5. If you had an antenna that had a bandwidth of 5 kHz at 7.1 meg, it would have a Q of 1420. And just to wrap that up, this is helpful because just comparing bandwidth on different antennas doesn't tell you enough. Is an antenna that has 400 kHz bandwidth on 20 meters more or less selective than an antenna with 200 kHz bandwidth on 40 meters? What about 100 kHz on 80 meters? Back to the small transmitting loop antenna, or mag loop. If you're using such an antenna on an amateur band, like say the 40-meter band, you'll likely have to retune your antenna every time you even think about changing frequency. I've had the frustration of using a manual version of such an antenna, and it can wear thin very quickly. I'm bringing this up because it can also be a benefit. Imagine that you need to make a contact on a busy band during a contest. Often you'll find yourself setting up the filters on your radio, trying hard to remove all the extraneous noise that comes from strong signals nearby. What if your antenna could help with that? What if you thought of your antenna as a pre-filter, something that makes the job of extracting just that signal from the bit of spectrum you're interested in? My point is this. We're talking about an antenna that from one perspective can be a pain to use, requiring constant retuning, constant adjustment just to get on the air and make noise. From another perspective, that very same antenna is a way to filter out the things you don't want to hear and extract the signal you care about. How you approach this depends on your perspective, and just considering your antenna as a filter might help you see another side of your antenna system that you hadn't considered before. How you use this is entirely up to you. For my money, I'll be doing more experiments. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.